Hello everyone, I'm back with another video, continuation of the previous video, and we'll be seeing the codes over here. So the first program is activity selection. It goes like this. We'll create an array list that will store the answers, and j will be 0, I is equal to 1. Then we'll come in the while loop until I is less than n. The condition what we have to check is that is the next activity start is strictly greater than or equal to the previous n, then that will come in the answer or it won't come. So that's why 10 to 20 is sure to come, the 0th index. Then 12 is less than but not greater than equal to as per this condition. So we won't add it in the answer array list. Then 20 to 30 is satisfying the condition. So it will come in the answer. So this is the code and this is the major condition that you have to remember until I is less than n. So let's run this once. So we get 0 and 2. Okay. Let's go to next program, that is block swap. I hope the problem statement is already clear to you, so we'll see only the codes. So over here, we'll be given an array as input, the k as input. So maybe the k is more than the array length. So we have to do k mod arr.length. This is a very important statement. And then we'll call the reverse function. Reverse function basically reverses the array given to it from start index, end index. Okay, it's very simple. You can go through it once. And what we have to do is that we have to reverse the array from 0 to k minus 1, then k to array.length minus 1, and then 0 to array.length minus, that is, at the end we have to reverse the complete array. That's how we'll get the answer. And then we can, instead of this, we have to put the for loop, iterate on each and every index, and then print each element. Okay, so let's see how it will ask me the values. So if I put 5, then 10, 20, 30, 40, 50, and k value as 3. So it will come 40, 50, 10, 20, 30. So here you go. Let's come to the next program, that is the hourglass. So we will be given a matrix. We have to find the hourglasses of 7 elements and then we have to print the sum, that is maximum. So you have to consider this variable max. Then note over here r minus 2 and c minus 2, very important. Then this simple formula. This is the major element that you have to memorize. And then each time we'll update the max variable with map.max, max comma sum. Okay, so very simple for loop, nested for loop traveling to the matrix, and this is the thing that is finding the hourglasses and picking the sum. We print it. Okay, let's put some input. Supposingly 3 rows, 3 columns, then element 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll get 35 as the answer. That is 1 plus 2 plus 3 plus 5 plus 7 plus 8 plus 9. Okay. Now we'll come to the Sieve section. So we'll do simple Sieve, and I'm telling you, this is the only program needed. It will work for segmented Sieve also and also for incremental Sieve. So the program won't be asked like specifically to do this type of Sieve. You have to read the problem statement and use it. So what we do over here, we take an input n from the user. Okay. Then we create a Boolean array up to the n entered by the user. Now we'll put all the values as 2 over here in the Boolean array. Then we'll traverse from 2 to square root of num on the Boolean array. If the element is true, then we'll make false all the next multiples. So note over here, j is equal to I square less than num and j is equal to j plus I. Very important step. Okay, I hope this is very clear to you, so no need for any extra explanation over here. Then we are simply iterating to the Boolean array, and wherever it is true after the modifications, that is the prime number. So let's run it once. So I put 10, then 2, 3, 5, 7. That is the point. Okay. Now if they ask incremental seed for chance, okay, so you can put the same program, it will work. And if they ask segmented seed, the only thing you have to do is that make this code and put n is equal to num over here equal to 1000 on your own. Make this code run, will fill all the numbers from 2 to 1000, okay, 1000, take it 10,000, okay, and then whatever range we have given m and n, say supposingly 20 to 45, so run the loop from 20 to 45 and do the same thing, okay, for in case of segmented seed. So this is done. Come to next, leaders in an array. So we are doing 3 inputs over here. I have done individually. We can simply do, you can do this one statement, okay, no issues. So we are taking input, filling the array. Now the last element, the cornermost rightmost element, is the maximum element. That is always the leader. So we'll put this in max and I'll add it in the answer also. Then we'll iterate from right second last element onwards and check if that is next greater element. If that is so, then it's put in place of max, add it in the answer. At the end, we get the answer array list, but we want the output to be in reverse order. So we'll use the collections class and we'll do reverse order, that will reverse order element, and then print, or in your case you can also do return also as per the program you're writing. Okay, let's see the next element. We have the next program, majority. Over here, a very simple concept that in the array all the elements are there. We have to find the frequency of each element. So we'll use the concept of hash map over here. Okay, we'll iterate on nums. Over here nums is the array name, and we'll do this one line that will put frequencies. So if count.getOrDefault of num is 0, then we'll put 1 with num comma 1. Otherwise, we'll get that value and we'll increment it. So that is how we are filling from one line the hash map, and then each time we'll check if count.get of that element, current element, is greater than nums.length of 2. Remember, we don't have to do equal to, only greater than. Then we'll return num, and that is the answer. If there is no such element that is greater than nums.length by 2, then there is no majority element and we'll return -1. So this is the simple function, that is finding the majority element. And this part is the simple input that you can take. Next here is maneuvering. So over here, a matrix will be given, supposedly so this is a 3 cross 3 matrix, and what problem statement says is from this cell you have to reach this cell. How many ways are there? Okay, so when you have a matrix like this, only one row, then there is only one way to reach from here to here, complete horizontal. Or in case you have such type of matrix, only one column, then there is only one way, complete vertical. Okay, that's why the break case goes like this. Otherwise, you have to do this. A very simple 2 lines code. You can simply memorize it. m-1 n, m comma n minus 1. So once -1 in the m, next -1 in the n, and you have to return this area. Okay, calling the function, recursively calling, and then adding it, because this will get answer from this half and the vertical half. That's why we are doing -1 once in column, once in rows. Okay, so this is very. Now the next program is maximum consecutive ones. Okay, so what we'll do, we'll take inputs n, then we'll fill the array, user input, and then we'll take k. K over here is number of flips that we can do. Okay, so we'll take three variables s in start, end, and max variable, store the max number of ones after flipping k bits, and this will basically track number of zero. So we'll make a while loop, and this is the major program section that you have to memorize. So while end is less than n. So sliding window type of approach we are using over here. Firstly, if array at end is 0, so we'll increase the count in 0. If 0 is more than k, then we'll do check that the start element, that is the array at s, if that is 0, then we'll decrease 0 and then increment s. Coming out of the if block, we'll put max comma n minus s plus 1, and this is actually after flipping. This is the region that we get. Then we'll do n plus plus, and at the end, after completion of this while loop, in the max we'll have maximum number of ones. So if we run it, it will be 5, 1, 0, 1, 1, 1, 0. Okay, and k is equal to 1. So we'll get 4. How we get 4? 1, 2, 3, 4. This bit was flipped because k is equal to 1. So this is the section that you have to take care of. Okay, coming to the next program, that is maximum equilibrium sum. So we'll fill the array taking user input. Then we'll do t is equal to 0 and max. Now what we have done over here, in S we have added complete sum, all the elements sum, and over here we are adding prefix. T is basically prefix, taking care from left to right, and S is basically taking from right to left. So we are adding the first index, that is the ith element. Then we are checking if S is equal to P. If that is so, means we are at an equilibrium point, and then we have to update the max with either S or P. You can put anything, and then we have to decrement S with the element that we have considered currently. So this is the section that you have to take care of. At the end, if max is not updated, max is remaining the same, that means we did not have any single equilibrium point. So we'll put max as -1 and then we'll print. Otherwise, this won't be taken care, and directly we'll get maximum equilibrium. Okay, you can try it once and it will be very simple for you. Next is maximum product subarray, and this is a very simple program. So this is the input. Now t is equal to 1, s is equal to 1. So this is taking care from left to right and right to left. Okay, now t is 1, s is 1. What we have to do is that whenever we get a 0, that means we have to restart left and right products, and we'll put equal to 1, equal to 1. Otherwise, we'll keep multiplying the left elements, the right element. Over here, this is the formula n minus I minus 1 to get the elements from the right hand side when the loop is forward. Okay, then we'll update the max variable like this, and then when the loop ends, we'll have maximum product in the max variable. We'll print it. Okay, now there are two programs, quick sort and selection sort, basically for sorting. So a very simple trick that you can do is, instead of writing this program, okay, this function completely, what you can do is you can directly do taking array input, then instead of this line that is calling selection sort and doing in place sorting, you can simply write arrays dot sort and array name. You can, if I show you an example, 5 elements, 9, 8, 7, 6, 5. It will be sorted in ascending order. Okay. So the same thing you can do for quicksort or selection sort. Basically, you have to sort the array, and the test cases would be passive even if you don't use the actual algorithm. Okay. So we covered these bunch of programs that was using concept of arrays. Okay. These two programs, maze solving and nqueen, these are based on backtracking, and this won't be asked. A bit very tricky programs. So we won't be taking consideration of the codes of these programs. Now we come to binary palindrome. So we'll be given a number n, say n is equal to 5. So its binary representation is 1, 0, 1. And if we do from right to left, again we get 1, 0, 1. So that means it is a binary palindrome. If I take 9, 1, 0, 0, 1, again 1, 0, 0, 1. So it is also a binary palindrome. If I take 10, I'll get 1, 0, 1, 0. And from right to left, it's 0, 1, 0, 1. So it's not equal. So it's not binary palindrome. So over here, you will be seeing a bit manipulation concept used over here. I won't use this and show you very simple 2 lines code. Okay. See very properly what we'll do. We'll take string din variable that will have integer dot to binary string and then the number. So it will convert the number into binary representation. So if n is 5, so it will make 101 and put in bin in string format like this. Okay. Now we'll do, as it is a Boolean function, true or false. So we'll put return. So first we have to make string builder st is equal to new string builder, and we'll put bin over here. Okay. I will do return bin dot equals st dot reverse dot to string. Okay. Now let's see. If I give 5, it gives 2. Now if I give 10, it gives 4. So with these 3 lines of code, you can do these 5, 6 lines of code. So I suggest you better to prepare this 3 lines. It's very simple. Okay. Coming to the next, that is swap nibbles. Another very simple code. In this we'll do the bit manipulation concept only. So supposingly you are given 100. Okay. Then I know the output, it will come 7. What we are doing over here, we are taking 8-bit number, that is 1, 2, 3, 4, 5, 6, 7, 8. Okay, these 8 bits are there, and individually 4 bits mean a nibble. So what we have to do, if I put 1, 1, for example, we don't know what number is it. So after swapping, it will become 1, 0, 0, 1 and 0, 0, 0. So the nibbles will swap its place from left, right, right, left. Okay. So what we have to do, simply take a variable a and with 15. Okay. Then left shift by 4. So it will do the swapping of right 4 bits to left side and then leftmost bits to right side. And then when we'll do the or, it will create combination of the swapped nibbles from left, right, right, left, and we'll get this if the input was 100. Okay, I'll show you. 100. Now let's say, so these 3 lines and A or B will give you the right answer. take care of the three lines, the logic. You can try run once if not clear to you. So coming to the next topic, that is root multiplication. So in case this is asked to you, you can simply take A and B as inputs and directly print A into B, because this algorithm simply gives you the product of the two numbers. If the two numbers are integers, then this line will give you the correct answer and make all the test case pass. So no need of doing these things. And majorly this topic will be asked in MCQs. And so this is the YouTube link. I'll put in the description also. So you can refer this link and then practice numericals based on COA, if you remember COA. Okay, we see the next program, CRT. Again, this is not a very important program from code question point of view. From numerical, it's important. Chinese Remainder Theorem topic. Otherwise, we can see once quickly. Will be given A array, M array, size n, and product of all the elements in the n. Okay. What we have to do, we have to put x is equal to 0, and in this variable, we'll get the final answer. Now, from I0 to less than n, so we are traversing on the array. Okay. Now we'll take a capital M variable and we'll do p by m of I, and we'll do initialize y is equal to 0. Now, from 0 to less than m of I, we'll iterate on the jth element variable, and if capital M into small j mod m of I, that is equal to 1, then we'll update y and we'll come out, we'll break, and then at the end of this loop, we'll have a value of y. So we'll update x with x is equal to x plus a of I into y into capital M. At the end, we have to do return x mod p, and that's how we have to do this program. Otherwise, there's very low probability that this would be asked you in any exam. Just go through it once. Okay, this is the main method, taking the inputs A, M, N, P. Okay, coming to next is Euclid. This algorithm basically finds GCD of two numbers. Okay, and the two numbers will be A, P. Now, the more important topic over here is extended Euclidean algorithm. What it does is, we have to create a static class triplet that will have three variables x, y, and GCD. Considering this statement, ax plus by equal GCD of a comma b, we have to find the value of x and y known A and B. So what we do, if B is equal to 0, so from Euclid's algorithm, if B is 0, then GCD will be A. Okay, if B is 0, GCD will be A. So what you have to remember over here is B equal to 0, then GCD equal to A. Okay, then if B is 0 and GCD is A, then AX equal to A, so X is equal to 1, Y is equal to 0, GCD is equal to A. So answer dot, because we have the triplet object named answer, and we'll return answer because this is returning the triplet object. Now in case B is not 0, so what we have to do, we have to make two objects. One is small answer that will keep recursively calling the eGCD function, and what we have to do, note here, remember over there BA, that is B0 then A, and over here BA B, remember this BA, and then over here BA B, like this, B A mod B, so B A B, like remember these two things, BA BA B. Okay, then whenever this function will complete recursively calling and end, then we'll create an object answer, and then what we'll do, you have to memorize these lines. Okay, x will have y value from small answer, GCD will be same, okay, and y will have first x from small answer minus a by b into y from small answer, okay. Remember this formulas. Then once done, then you have to return answer, that is the triplet object name, okay. And this is the Euclid algorithm. As I said, B0 then A, and over here B A B, okay, B A B A B. Now this is the main method, A B, calling the eGCD function returns triplet object, so we are calling equal to in that variable, and then we are separately printing x, y, and GCD. So answer dot x, answer dot y, answer dot z. Why we are putting answer dot? Because when we do answer dot, then we can extract, we can ask the object answer what all variables you have, and then we can get that as printed on the screen, okay. So that's how the eGCD extended Euclidean algorithm works, okay. Coming to the next program, that is Euler Phi. Again, the programs over here in the number theory are more probable to come in any of the MCQs and not in the codes, but we cannot comment on anything very accurately, so it's better that you prepare the codes, okay. It's very small, so let's see. So there's a formula, if you know, that is phi of n is equal to n into 1 minus 1 by p1, then 1 minus 1 by p2, and so on. So the same thing we have to do over here. We'll put n in the result variable, okay. Then we'll do 2 to I square, that is we are finding the prime number, prime factors. If n mod I equal to 0, that means we found our prime number. Then what we'll do, we'll divide by I, that is p1, and then we'll multiply by p1 minus 1, because over this statement, if you solve it, it will come p1 minus 1 by p1. So we'll divide by p1, that is I, then I minus 1, that is p1 minus 1. We are multiplying result. So we are doing this part, and then till all the prime factors equal to I is removed from n, we have to do this statement, okay. As it's done, we'll do for each I value, okay, for each prime factor. Supposing there's an element, say n is equal to 140. So this will have 7 into 2 into 5, and this will have 2 power 2, okay, because 4 5 is 20 into 7 140. So what we are doing over here, we only want p1 p2 p3, that is 7 2 and 5. We ignore the powers, okay. So at the end, if n is still greater than 1, that means the n is itself prime number, okay, after all the iterations. So what we have to do, so note, if phi of prime number, then we get the answer as prime minus 1. So the same thing we are doing, we'll divide it by n, that is we are making the result equal to 1, and then we'll simply multiply it with n minus 1, that is prime minus 1, and then we have computed the phi of n, and then we'll return the result variable, okay. Simple formula that we are using, and then we are coding the formula itself. So for phi, it will work 5 4, okay. For example, if I make it 35, you all know 35 is 7 into 5, so the answer will be 6 into 4, 24. Let's see, yeah, 20, okay. Or in case we put 140, then it will be 8, right? So you can apply the formula, common formula, this one, and then you can check. So let's see the next. Okay, so we have covered the number theory. Recursion part will come at the end, okay. Now we will see the questions related to strings. So we have these programs related to strings. The first one is longest palindromic substring, or also called Manacher's algorithm. So the Manacher's algorithm is a bit tricky. So I'm not discussing the Manacher's algorithm, that is time complexity of big O of small n, but what I'll be discussing here is our n square time complexity. No worries, this will also work in the exams. Now we are taking string input from the user, and then in the n variable we are simply putting the size of the string str.length. Then we'll create a dp. So don't get fear with the term dp, it's simply a 2D matrix of size n cross n. Then we'll create a variable max to keep a track of the new longest substring that we'll find in intermediate steps, and in the answer we'll keep putting that new intermediate string. Okay, because at the end we have to return or print the longest palindromic substring. Okay, so it's very simple. And note over here what we'll do, it is a 2D matrix of n cross n size, but we are only considered, or we are more focused about the upper right triangle. Okay, so we'll be filling the upper right triangle, and whenever required we'll retrieve the already stored values from the cells and use it to find a sub problem's answer. Okay, so the difference variable, to understand the code properly you have to understand each and every line, and then if you understand it line by line it will be very simple for you to memorize or recall in the exams. Okay, so the difference variable is 0. It will be less than n, that is the length of the array, or sorry, the length of the string, or we can also say character array, right? Difference plus one. So in case I have a string a b c d, so my difference variable will have 0, 1, then 2, and then 3. So what is 3 signifying here? The last index d. Okay, now we'll take two pointers I and j. I will be 0, j will be difference plus I, and we have to keep a track of j. That's why the condition is j less than n, because we are incrementing I and j difference and storing in j, so we have to consider j less than n, increment I, increment j. Now we have a very simple three conditions that we'll be using to fill the 2D array deeply. So supposingly I double equal to j. So what is this scenario? Is like if I equal to 0, if I equal to j, that means 0 comma 0 cell, okay, or 1 comma 1 cell, or 2 comma 2 cell, or 3 comma 3 cell. So what are these positions? These are the diagonals. Okay, diagonals. And this signify a substring from 0 to 0, from 1 to 1, 2 to 2, 3 to 3. That means only one character is coming in the substring. So whenever there is one character in the substring, that is always palindrome. That's why we are putting 1, signifying that substring with only one character is palindrome. Okay. Now if difference equal to 1, that means these scenario 0, 1, or 1, 2, or 3, 4. So like substring from 0 to 1, or 2 to 1, 1 to 2, or 3 to 4, these will have two characters and difference of 1. So if only two characters are there in the string, then what we have to check to make it palindrome? Only if those two characters are equal to each other. If that is the case, then at that cell we'll put 2. 2 means signifying that that substring of size 2 is a palindrome. Otherwise, we'll put 0. Okay. So these were the scenarios when the difference was 0 or the difference was 1. In case a substring is of size more than 2, that is 3, 4, 5. Okay. So let's assume substring is of size 4. Substring is of size 4. Okay. Suppose substring was ABCD or ABBA. So what we'll do, we'll first check if the corner elements, this A and this A, that is the ith element and the jth element is the corner, if those are equal. Okay, if that is equal, Then now the problem is just checking the substring. Okay, so what we'll do, we have already solved this problem and stored the answer in the dp2d array. And to come to this substring, what we have to do? We have to do I plus 1, and j minus 1, j minus 1. And that's what we are putting over here to fetch the value from dp. And if that value is greater than 0, that means this substring was also a palindrome. And that's why we have done this condition with an AND over here. Okay. And if this is true, then at that cell, what we have to do? 2 because of the corner characters. Corner characters, this was the condition. And plus dp at I plus 1, j minus 1. It's very simple. We have to memorize this. And then this cell will be updated with the desired value of the cell. So over here, this might be 4 because of this example. Okay. And then after filling the 2D array, so these are the if-else conditions that will be filling the 2D array, that is the DP. Now over here is the section where we will be checking if that is max or the previous one was max, so we won't update it. So like if dp at ij is greater than 0, that means the current substring is palindrome. And if the length of that current substring is greater than the value stored in max originally, then we'll update the max variable. We'll update the max variable as well as we'll update the answer variable with new substring. And make sure you write j plus 1 because substring function only takes this minus 1. So if I write j plus 1, we'll consider j also, jth index also. Okay. At the end of this nested for loop, I'll have my answer. So I'll try run. So if A, B, B, A, C, D, E, F is there, so I'll have A, B, B as the longest palindromic substring. Or we are performing Manacher's algorithm to find the longest palindromic substring, but not following the coin complexity given by Manacher. Okay, there you go. Now coming to the next program, that is move hyphens, and this is one of the very simple programs. What we have to do, we are taking a string from the user that will have hyphens in any of the places, be it in the start, mid, at the end, near to end. And what we have to return is that we have to put all the hyphens. Suppose this was a string. So the output will be 2 hyphens in the start, followed by the remaining string, 1 space, 2 space, 3 space, 9. So this will be the answer. So what we are doing, we are making a count variable to count the number of hyphens. Okay, and we are using the for each loop for character C in str.toChar array, making a character array from str using this function dot. If that character C is a hyphen, then we'll do nothing. We'll just increment count and we'll ignore it. That is a jump statement count. So the call will go back to this for loop. And otherwise, if in case that C, that character was not hyphen, then we'll simply add it in our empty answer string. And at the end, what we'll do, up till count variable is not equal to 0, we'll put a hyphen in the start decrement count. And finally, we'll have an answer updated with hyphens coming at the beginning. So this is a very simple program. Just we have to put the hyphens in the beginning. Okay, let's run it once. In case I put hello, how are you? So the answer will be like this. And because I haven't put any spaces between hello, how are you? So there's no spaces coming also, but the hyphens are coming in the beginning. Okay, let's go to the next program, Palindrome 1. Okay, so this is lexicographically first palindrome. What's the name basically of your first palindrome? That means according to dictionary, we have to find the first palindrome. So supposing the input is A, B, B, C, C, D. So the answer will be A, B, C, D, C, D, A. Okay, this will be the product. But note over here, if I put one E over here, then this element character E and this character D both will have an odd frequency and will have more than one character, those who have frequency odd. In this case, we won't get a palindrome. So no answer. Based on this logic, we'll do it. So we have to calculate the frequencies and we want to extract them in sorted order. So what we'll do, we'll use a tree map that will on its own keep sorting the characters, the keys. Okay, so we'll make this tree map character integer key value to put the sorted characters and keep a track of the frequencies. We'll take a string from the user and we'll update the character in the tree map. So this is filling the map. Okay. Now after this is the actual working after filling the hash map, tree map over here. Now if the input was AA, BB, CC, D, E, so A is 2, B is 2, C is 2, D is also 2, and E is 1. Okay. So we'll put prefix, suffix, and middle, three strings, and keep a track of how many characters whose frequency is odd. Okay. Now we'll extract one by one the characters from the map, map.get C, and we'll iterate for each loop map.keyset. On the keyset, we'll iterate and get one by one the keys, that is the characters. N is equal to map.get C. Now we'll put a for loop 0 to less than n by 2. We'll put those many characters in T prefix, and in case n has a value that is odd, because n will be storing the frequencies of C character. So if that is odd, then odd string is plus plus, that is we are incrementing the count in the odd str, and then also putting that in the m string. That next, at the end of this for loop, we'll have our t string and m string updated. It's very simple. The only thing we have to check is if the odd str that has a count of characters whose frequency is odd, if that is more than one, then we cannot form a palindromic string. Otherwise, we can. So if we cannot, we'll completely exit from the function using the return statement. Otherwise, what we'll do, we'll create a string builder object, ST, and then we'll append prefix, and in the suffix, we'll put the reverse of that P, and we'll print prefix plus middle plus suffix. So that's how we have to do this program. We run it. A, B, B, C, C, D, D, E. You can see A, B, C, D, E, D, C, D. This is the output. And based on dictionary, this will be the first output. Okay. So here we have two programs based on Strobogrammatic Number. So we'll see each and every program one by one. So we have Strobogrammatic 1, and over here we have to return n if the number is not Strobogrammatic and the y if the number is Strobogrammatic. So what we'll do, we create a hash map of character and character key value. Then we will put the mapping 0 with 0, 1 with 1, 6 becomes 9, 8 is 8, and 9 becomes 6, as 6 and 9, vice versa. Now, as the input is in string format, supposingly the input is 101, so we have to check if this is Strobogrammatic. So what is the concept is, we have to iterate on the corners one by one and shrink towards the mid. So we'll take two pointers S and E, left side, right side, -1. So until and unless they both cross each other or S and N is pointing towards the same position, we have to iterate. This is the leftmost character, the rightmost character. Then we have to check if map has that character present. Supposing A is equal to 5. So over here, can we see 5 as the key value? No, because 5 on 180-degree rotation, as per the Strobogrammatic concept, it doesn't have a valid image of a digit. So first we have to check if map contains A or no. We have to check if both A and B are compulsorily present in the map. Then only we have to come inside and check if the value from map.get A is equal to B or map.get B is equal to A, then do nothing. Otherwise, if they are not equal, then that means it's not a strobogrammatic and we need to have output n and will come out of the function. If map doesn't contain these factors, then also it is not a strobogrammatic number and s plus plus n minus 1, that is, we are shrinking and coming towards center. If this while loop runs without printing n, then at the end we can print y. That means we have a strobogrammatic number. So let's see. Supposing I write 101, it is a strobogrammatic number. If I write 888, then it is a strobogrammatic number. And if I write 858, then this is not a strobogrammatic number because of 5. Okay. Now, what is strobogrammatic number 2? Is see. Over here, user will give us a value n, and we have to print all the n-digit numbers that are strobogrammatic. Okay. So we'll create an array list of strings and we'll return that result. That array list will store all the n-digit strobogrammatic numbers. Okay, so what you have to do, these are the two break cases. If user has given n as 0, that means there is no strobogrammatic number because at least n is equal to 1 should be there, then only we can say a number valid. Otherwise, there is no number that is having a space of 0. Okay, so we'll create an array list, we'll add null string, we'll return. Otherwise, if n is 1, we'll create an array list, we'll add 0, 1, and 8 in this order, and then we'll return. If that is not the case, then we have created a function num_def doing this. So we'll create an array list called middles, and we'll call again, recursively call this function with n minus 2 and l variable. That is also n at this time. Okay, note over here, n comma n. Then what we'll do, we'll iterate on this middles named array list for each loop, and if n is not equal to l, then result.add 0, 0, middle, and 0. Note, I haven't put the cases. That means I am trying to simply say that only this line comes under this if block. Okay, for your clarity, I mentioned the braces broken down. And then next what we do is result.add 1, middle 1, 6, middle 9, 8, middle 8, 9, middle 8. So this is the segment that you have to remember. And these are the break cases. Okay, and in this very line, calling back the function again and again until the break case is meet. Okay, at the end, when this function ends, then we will have final answer in RDS, that is result name array list. Okay, so we can run it once. If I put 1, 0, 1 of case, break case, I put 0, then empty, and if I put 2, then 11, 69, 88, 96 is output. This is not very important part of Strobogrammatic. The more important is to identify the number is Strobogrammatic or not. Okay, so focus more on Strobogrammatic one. Coming to next program, that is weighted substring. Many of you might feel this is a very tricky program, but trust me, once you are clear with the concept, nothing is tough. So let's see. Okay, so over here I've created a help name function that is taking int k and string str. We are finding the length of the string in n variable, a sum variable, start index, end index. Okay, and a hash set to store the strings. Now what the question says that we have to find all the substrings whose weight is equal to k. Okay, weight is equal to. And what do you mean by weight? So over here, what I have done, str.char at end. Okay, end is less than. Okay. And if that is true, then str.char at end minus a. So we are getting the sky value and then plus 1. Because we are saying a has weight of 1, then b has weight of 2. Similarly, z has weight of 26. That's why we are adding a 1 over here. And this line over here, if it's a, it will be 0. If it's b, it will be 1. If it's z, it's been 25. Okay. So the sum variable is taking a sum of the weights of all the characters in the current substring. Okay. Now, if by chance the sum is equal to k, then that means that is a probable answer. So we'll add it in the answer hash map as set over here. Okay. Sorry for the incorrectness. And then we'll add the substring from S to n plus 1. Please make sure n plus 1, don't put e over. Okay. Now, if in case sum is greater than k, then what we have to do? We have to do sliding window. So that's what we are doing. We are removing the sum. From the sum variable, we'll remove the current element weight, increment the s value, and again we'll check if the sum variable is still k, then we'll put that also in the hash set. Now you might think why we are using hash set over here. So supposingly I have a substring a, and by chance after some time I again have a substring a, so it will have same weights, but it should come only one. So we want unique substring whose weight is equal to k. So this is the code segment. You can see one, and then we'll return answer.file that will simply say number of unique substrings with weight equal to k. Okay, so over here we are taking t a variable, number of test cases. Okay, number of test cases, then an answer array. Then for each time, for each test case, we are performing k str from user, calling the help and updating the array. So it's like for more than one input. Second segment, the second part of weighted substring is this code. I'll show you this also once. Just a second. Okay, so we'll come this also. Over here, we have been given a P string with characters, supposedly A, B, C, E, F, G, H, D, D. Okay, and this Q string will have digits. It will have 26 digits that will signify the weight of ith character, or in particular weights from A to Z. Okay, so this string will have 0 to 9 a digit from 0 to 9, and each in position will signify weight of character A, then character B, character C, and so on to character Z. So the 0th index of string Q will have weight of character A from 0 to 9 integer, and then 25th index of string Q will have weight for character Z, any digit from 0 to 9. Note the condition is 0 to 9 only. And in the previous code, it was any weight not restricting to 0 to 9. Okay, the key variable again as in the previous code, and then n is storing the length actually. We are sending p, q, k, n, and then calling this function. Now what this function do? Again, we are creating a hash set. Same concept, just a different thing we have to do is the entry of q string. So we are doing a n square type of thing. In the previous code, we give a sliding window, big of n type of thing, but here doing n square thing. I, j variables, okay. Now we'll have a position variable, getting the position for jth position character, okay. Supposedly the p dot caret j is a, so a minus a will give 0. Then we'll check from q at caret 0, that digit value, if we want to get an integer, so we'll do minus single quote 0. Then we'll update the s variable, that is the answer string, and if sum is less than equal to k, that means at most k size substring, k weight substrings, then we'll put it in the s hash set. Otherwise we won't, we'll get out of this loop, we'll break it. Okay, at the end we'll return s dot size. So the point to be noted is entry of this q and p dot caret j minus a. So a minus a, this would give 0, and then from the 0th index we'll get one answer from 0 to 9 digits. Okay, that's how we have to do. So you can try run if you have any issues. Very simple program. Okay, we are done with the programs based on string. What remains is the recursions. So these are a very bit tricky codes, but I have tried to provide simple and small program snippets over here. So let's first see Karatsuba. Again, this is same like Boo's algorithm. This also has to take two variables a and b. We have to return product. So instead of performing this Karatsuba algorithm, you can simply do a println. So you can do println a into b, and this will work perfectly for any test. Okay, so we will not get into the code for this program. Josephus, again very simple program. The concept is that n people will be standing in a circle. Every kth person will be killed. So the break case is like if there's only one person, then whatever the value is k has, one person cannot be killed because there is no person more than one to kill n itself. So over here we'll return 1, and then we'll possibly call Josephus. So try to memorize the statement Josephus of n minus 1. So each time we'll reduce n because we have to check for remaining persons after killing kth person. So Josephus of n minus 1 comma k, and then over here plus of k minus 1 whole bracket mod of 10, and again plus 1. So you can remember as n minus 1 k, then k plus 1, sorry, k minus 1, and then whole brackets mod n plus 1. So you will take n and k from user and then call Josephus. Okay, you can go through it, very small snippet. Next is permutations and combinations. Okay, so let's see these properly because these are the two tricky programs. Let's see first the permutation. So over here we want to print unique sorted permutations. Okay, so if like the input is ABC, then the output would be, we'll see from the program input itself. So if I give ABC, this will be the output. First ABC will come, then ACB, BAC, BCA, CEB, then CBA. Okay, so the logic used over here is swapping concept. So I'll create a function, helper function called swap. It will take a character array, two indexes, and it will swap characters present at those indexes from the array. Now I've tried to provide a very small snippet, small code for this type of program statement. First we have to create a tree set of string such that it's come in sorted order. Then create a function called permute. We'll take character array, starting index, ending index. Initially it will be 0. It will be arr.length -1. Okay. Then if start is equal to end, so this is the breakfix. Then we'll put that value in the set. So over here what we have to do, string dot value of arr, because arr was a character array and we want to put strings in the set variable. So we'll use string dot value of arr character. Okay. If this break condition is not reached, then what we'll do, else for loop I is equal to start, I is less than equal to end, I plus plus, then we'll do these three lines. It's very simple. We have to swap the array element at start with I. Then we have to recursively call the permute function arr with start plus 1, next element. And if we think from recursive tree point of view, then when all these steps are completed, then we have to do backtracking for next branch. That's why repeat this line arr start and I repeat. So these two lines are duplicate over here as it is, and start plus 1 is the change over here. Okay, so that is how we'll do permutations, unique sorted permutations. Then calling, we'll send the character array 0th index and s dot length -1 last index. Then once this function is called, the tree set named set will have the unique sorted permutations. So we'll iterate on it for each loop and we'll print each element present in the set one by one. Let's run this once in case we have repeated characters. So if AL is the input, we'll have these three outputs. Okay, and the final program that we have for us to do is called combinations. So it's simple and very small. We'll check that nums array, count variable, size variable, start, comb string to keep track of the combinations we are finding. Very important over here. The break case. Okay, and then same as previous permutation program, in the else block we'll put a for loop, but over there three lines were there. Instead of those three lines, we have one line over there. So like this, comparing the two programs, you can remember this code very easily. Okay, num count plus 1, size, and note over here I plus 1, and then updating the string com to get the next combination. So let's see how it takes input and then output. If we give size as 5, then the array elements 2, 3, 4, 5, and we want combinations of size 2. So 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 2, 4, 3, 5, and 4, 5. So these are the probable outputs. Okay. So these were the programs based on recursion, string, bit manipulation, backtracking won't be asked to you, and based on array. So focus more on arrays. These two programs very simple, and recursion part and string part. Okay. focus more on these programs. It's very simple, just go through them 1 or 2 times.